Okay, we have a new limit here that we're going to look at, and it's the limit as x approaches 4 of the square root of x plus 5 minus 3 divided by x minus 4. Okay, so if we try and plug 4 in here, we're going to end up with 0 over 0 again. And it doesn't take much to see that. If you plug into the numerator, you're going to get the square root of 9, which is just 3, and you're going to end up with 3 minus 3. And in the denominator, you're just going to end up with 4 minus 4. So this, if you try and plug it in, you're going to get 0 over 0. And if you watched the last video, you know that this means you got to do more work. When you try and solve a limit and you get 0 over 0, it means you got to do more work. So let me rewrite the limit here. Well, let me just actually erase this to clean it up. Okay, so what can we possibly do to this to simplify it? It doesn't look like there's a whole lot we can do. We can't square everything. That will change it because we don't have an equation, so we can't square both sides. We can't really divide x minus 4 into this. It's not going to work nicely at all. So what can we do? And I want you to think about it for a minute, actually. And I want you to think back to the last video, what we used to solve the last problem. If you saw the last video. And maybe even pause the video right now and think about it for just for a minute. Just ponder what are some of our options? Are there any that you can think of? And that's what problem solving is. So give that a shot. Okay, hopefully you paused the video and you thought about this for a while, and maybe you even came up with the answer. But now we're gonna solve it. So the first step is to remember again the difference of squares. We looked at this in the last video. A squared minus b squared is going to factor to a minus b times a plus b. And how does this help us? We don't have a squared minus b squared, we have a square root. But what we do have is we have in what we can think of as an a minus a b. And let me show you over here. If we say a equals the square root of x plus 5, if a equals the square root of x plus 5 and b equals 3, then our numerator is a minus b. And we know that if we just go ahead and multiply by a plus b, what's going to happen is that those two terms will square. And why is that helpful for us? Well, because if we square a square root, it will get rid of it. And that's what we call rationalizing. So this is a problem where we're going to actually rationalize the numerator in order to help us solve this. So let's go ahead and do that. So step 2 will be to utilize everything I just talked about. So it's the limit as x approaches 4 of the square root of x plus 5 minus 3 all over x minus 4. And we said we're going to multiply by a plus b. So let's do that. So this will be multiplied by, and what was a? Well, a is square root of x plus 5, and then plus b. So plus, let me make that more clear, plus 3. But we can only ever multiply by 1, otherwise we're going to change things. So we have to multiply by this over itself. So x plus 5, square root of x plus 5, plus 3. Okay, so now everything is nice and neat and mathematically legitimate because we're just multiplying by 1. And let's go to step number 3. And you don't have to think of these things in terms of steps, but I think because these videos, it's just a lot of blank space, it helps organize the thoughts in the process a little bit. Anyways, okay. So the limit as x approaches 4. Now the numerator, we know what it's going to turn out to be. We know what a is and we know what b is, and we know that when you multiply conjugates you're going to get a squared minus b squared. So instead of trying to multiply this out, I'm just going to utilize that fact. And so when you square root, it goes away, so we're going to get x plus 5. And then we're going to get minus b squared, and b was 3, so we're going to get minus 9, which is 3 squared. Okay, and this whole thing will be divided by x minus 4. That's just left over, so x minus 4. I'll write it in white because that's left over from from up here, and then that's gonna be multiplying the square root of x plus 5 plus 3. Okay. Up over here, we're gonna go to step 4, and this will be the limit as x approaches 4. And then let's simplify the numerator. Plus 5 minus 9, that's minus 4. So this will be x minus 4 in the numerator, divided by x minus 4, and hopefully bells are going off in your head now, times by square root of x plus 5 plus 3. Okay. And now we're left with an x minus 4 over an x minus 4, and these divide to 1. And don't get confused. Some people get confused when you divide something out of the numerator. The reason I always say divide to 1 is because there's a 1 left over in the numerator. And there's a 1 in the denominator, but if you divide by 1, it's the same thing as just not having a 1 there. But a 1 in the numerator is much more significant. So don't be confused by that. Alright. A lot of people like to say cancel. I say divide to 1, because I think when that situation arises, helps you remember what to do. Sorry, this is just looking too messy for me, and that's why I keep erasing it. Okay, so we're left with 1, the limit as x approaches 4 of 1 over the square root of x plus 5 plus 3. And now we're finally ready to substitute. And the reason we can substitute now is because we're left with an x plus 3, not an x minus 3 like we started with. And when you do this substitution, you're going to wind up with an answer of 1 over 6. 1/6. And that's because this becomes the square root of 9. You take the square root, and you end up with 1 over 3 plus 3. Which is equal, of course, to 1 over 6. So that's the limit, and that's how you do it. So if you get something with a square root, especially if it's a fraction, this is probably the method you're going to use. And it's not that you have to memorize this method, but what you should do is just think about what's going on. Why are we multiplying by the conjugate? Well, because not only you're going to square the term, but you're going to get rid of the middle terms, which means all the square roots in the numerator will go away. And everything flows from there. So it's better to understand why we did this process than it is to just memorize it as a method to solving. Okay, see you in the next video.